Hey guys, this is your News Pledge Nemo, and I am here to give you the daily news. So, for today's news, I'm going to deviate from the usual crap about clowns and future Hitlers for president, and I'm going to give you some news from the Science Daily. So, engineering news, that's because that's what we're all about. So, something we are all familiar with is 3D printing. I know that you guys use it daily to create parts, especially for projects that you're building in some of your classes. 3D printing is also very useful if you just want to build a fun project outside of class. I know that one of my teachers in high school built his entire phone case out of a 3D printer. And yeah, so every day people are developing new ideas, new projects that you can use to augment the efficiency of 3D printers. And one of these things is 3D printing robots with shock absorbing skins. So currently most 3D printers, what they do is they melt plastic and then they mold the plastic into the shape that was programmed into the computer or the printer. And then from the computer tells the printer what to print out. But if you take a look at these parts, they're just plastic. So if you drop them hard enough on the floor, obviously they're going to break and they're going to shatter into pieces. And then you have the usual problem where the base that the 3D printer makes right under the part, and you have to take the piece off of that. Sometimes you have like a little debris and you gotta sand it down and you gotta do all this other shit before you have it done. But what these amazing engineers at the Massachusetts Institute of Technology have developed is, like I said before, shock absorbing skins. So basically, we all have these phone cases, right? Before, when the iPhone first came out, we looked at these. Obviously this is just part of a case, but we looked at these kinds of cases and we said to ourselves, oh my god, this is so cool, I'm gonna put it on my phone. And then we soon realized that when you drop it, they instantly break. So we learned from our mistakes, and then we moved on to these types of cases, like the bendy plastic, really hard plastic. You hit it on the table, nothing happens. You put it on your phone's totally fine. So imagine if, let's say that the plastic that the 3D printer is currently using is this, and you get something like this when you print it, but now when you print it, you get something like this, right? And obviously it's not going to be this bendy, but just ever so slightly that if it were to hit the ground, it wouldn't just shatter into a bunch of pieces. Part of the story is also that this can be applied to the drones that Amazon and Google are developing. So let's say that when the drone's like crashes into a wall or something, or crashes into another drone, or some crazy person with another drone wants to like videotape the drone and then head on collision with the drones, and then the drones basically hit each other, and you're just gonna get a mess and you're gonna lose a ton of money because the material's not that durable, especially if it's this kind of plastic. So if you think about it, what if the 3D printer was capable of printing material like this for those drones, just so that when they collide with each other, or for whatever reason collide with something in their way, it doesn't cause that much damage. And then what your end result is, you increase the life expectancy of those drones, you save a lot of money, and you just end up with a cooler design and something that's going to last a lot longer. But the main project for this team was basically their team's programmable viscoelastic material, PVM technique, allows users to program every single part of a 3D printed object to the exact levels of stiffness and elasticity they want, depending on the task that they need it for. So their example was a 3D printing a cube robot that moves by bouncing. And so they outfitted it with rock absorbing skins that use only 1/250th amount of the energy that it transfers to the ground. So as you can see, you're ending up with more efficient designs, and you're just paving the way for newer designs using this different technique for printing. So hopefully that was a good introduction. I will definitely post a link to this article so that you guys can read more about it. I didn't really want to get too much into the information, just give you guys like a quick, kind of like intro to it. If you guys want to look more into it, feel free to. And then I'm also going to post another video for another project, which is basically a glove that functions on electrically controlled tendons, which gives your muscles extra strength for people that have lost strength in their muscles. Let's say you get into an accident and you only end up with 25% strength on your hand. You put on the glove, you have a battery, you turn on the battery sends power to the glove, and then the more pressure you apply, basically the more grip strength you have. So that is basically the daily news for today. Hope you guys have a wonderful morning. Getting pumped for that run at 5:30 in the morning, and I will see you guys there. Peace out, guys.